We should be live. Yes, we're live. So I'm getting ready for the upcoming interview in application security engineering. Um, it's very much oriented on um, OWASP and MITRE attack frameworks. So you have to have a knowledge. You have to have knowledge in application security and general cybersecurity, and you have to have tools. You have to have knowledge in tools of SAST and DAST. Also, you have to be comfortable with DevOps principles, including CI/CD, test automation, shift-left security, cross-functional teamwork, and shared responsibility. I also have to be familiar with agile requirements, agile methodologies, and Scrum and Kanban, and so on. What I was so I should start with OWASP and then dive deep into differences between SAST and DAST, and at least read about SAST, because in general in my security repertoire I use dynamic tools like burp and dynamic techniques. Then we will dive into MITRE, and I'll also try to go through some DevOps type of things, like CI/CD, testing automation, and so on. All right. So I have come up with a full list of probable questions that might come up. It's about OWASP, MITRE, and some DevOps type of things. Also, I have come up with like a reading list of like different things that I want to read before I go to the interview, and I will read those stuff here as well, some of it at least. So let's just start. I'll start with OWASP. And what's that, by the way? This is password attacks. From that thing, these are completely not needed for me. These are completely not needed. I just need web and application stuff. I might need those stuff, but let's do that later. Do this later. Okay, let's start with OWASP top 10. So OWASP is oh, should I start from the interview type of things? Yeah, what is OWASP top 10? Why is it important? Can you explain OWASP top 10 and give examples of real world mitigations? Can you explain OWASP top 10 vulnerabilities with real world examples? How do you prevent SQL injection in modern applications? What is the difference between XSS and CSRF? And how do you mitigate each? This is a really good question to differentiate between a noob in web security and someone who knows what they're doing. How would you protect against broken authentication? Insecure deserialization. I should look into the techniques of exploiting insecure deserialization, and so on. Why is it dangerous? Explain the risks of security misconfiguration. How do you identify and fix it? Sensitive data exposure, preventing SSRF. Also an important question: what tooling or technique do you use to detect OWASP top 10 issues? And here I will mostly talk about burp and different tools. I will mention some of the static tools just to be just to sound professional, and I'll also say that I like to do manual penetration testing, which is the most effective way of hacking. Scenario-based questions. You discover an XSS in a third-party library. What steps do you take? Really good question. JVTs without expiration. What's wrong with that? Really good question. You're reviewing an API. What OWASP risks do you check first? Really like a legit question. How do you perform secure input validation on both client and server? All of those stuff are really legit. How do you integrate OWASP guidelines into SDLC? OWASP AS, I don't know what's this, but I'll look into it. How do you educate developers about OWASP top 10 risks? So all of these are really good OWASP questions. I think after mastering those, I will be ready to basically pass any web security oriented interview. Then we'll dive into MITRE. So the questions of how does MITRE framework differ from traditional threat classification, tactics and techniques in MITRE, how do you use MITRE attack and threat modeling or security planning. I have blogs from Hack the Box for those MITRE questions. How do you map detection rules to attack techniques? Really good question. Have you used attack to evaluate or improve your SOC's visibility? MITRE's Caldera for simulation. Actually, I think I have used Caldera from TryHackMe. So this is really cool. How do you align application security findings with attack techniques? Describe how you use attack with Purple Team exercises, PowerShell usage, how to use attack to triage it. Vulnerability in your app allows credential dumping. How would you map this attack in, how do you build detections for T command and scripting interpreter? This is also a really fucking good question. So MITRE, OWASP, and I have some DevSecOps readings to do. So OWASP top 10. So OWASP top 10 stands for Web Application Security, Open Web Application Security, what? Protocol? Project. Open Worldwide Application Application Security Project. Worldwide Web, Open Web Application. Turned into a worldwide application. Open Web Application Security Project. It turned into worldwide, which is, I don't know why they did that, but okay. Yeah, first one is broken access control. Websites have pages that are protected from regular visitors. For example, only site's admin user should be able to access a page to manage other users. If a website visitor can access protected pages they are not meant to see, then the access controls are broken. Being able to view sensitive information from other users accessing unauthorized functionality. Broken access allows attackers to bypass authorization, and allowing them to view sensitive data or perform tasks that they are not supposed to do. So IDOR is refers to access control vulnerability. IDOR is one of the access control vulnerability where you can access resources you wouldn't ordinarily be able to see. This occurs when the programmers expose a direct object reference. A programmer exposes direct object reference, which is just an identifier that specifies object within a server. Objects within the set. So you can actually see the objects within the server. For example, let's say we are logging into our bank account, and after correctly authenticating ourselves, like account ID on the first page ID, let's say that IDOR, secure direct object reference. There, however, is a potential huge problem here. Anyone may be able to change the ID parameter. Let's say that there is a banking application, and in this banking app, we use ID parameter through a request to see our own account. But if we change, like, let's say we access our information through the request using ID parameter, and we can actually control this ID parameter from the client side. If somebody changes this ID to some other ID, let's say we have ID 1, others have ID 2, they can access the information of user given ID 2. This is the IDOR, insecure direct object reference, IDOR vulnerability, which is top one thing. So accessing things that you are not meant to access is the top security in OWASP. Cryptographic failures. Crypto failure refers to a vulnerability arising from misuse of cryptographic algorithms for protecting sensitive information. Web applications require cryptography to provide the credential for their users at many levels. Encrypting data in transit. So of a secure application. Let's say we have a secure email application. When you are accessing your email account using your browser, you want to be sure that communication between you and the server are encrypted. That way, any eavesdropper trying to capture your network packets won't be able to recover the content of your email addresses. When we encrypt the network traffic between the client and server, we usually refers to encrypting data in transit. Since your emails are stored in some server managed by your provider, it is also desirable that the email provider can't read their client emails. To do this, your emails might also be encrypted when stored on servers. This is referred to as encryption data at rest. Data at rest, cryptographic failures often end up in web apps or webs. Data, this often data directly linked to customers. At more complex levels, taking advantage of some cryptographic failures, man-in-the-middle attack where nearby attacker would connections or a device they control. They will take advantage of weak encryption. This is really surprising that crypto failures would show up as a second, but yeah. So the realistic example of cryptographic failure would be that attacker has somehow finds a way to gain access to the flat file uh, database image or database file, flat database file, and they dump the database. They go and inspect the database for tables. They find the usernames and passwords table, and they capture the hashes, and then they crack it. They crack them. If the hash is a weak one, MD5 hashes, all of crackable password hashes are weak MD5 hashes. Crackable hashes. So another type arises like which hashes are crackable, because not all hashes are crackable. MD5 is one of the older ones. They are crackable, easily crackable on algorithms configuration. So whether a hash is crackable, it depends on the algorithm usage and whether salts and peppers were applied. Collision attacks. Shattered. SHA-1, salted SHA. MD5 is very crackable. SHA-1 and NTLM are crackable. Also, since SHA-256 or 200 with enough, not designed for password hashing. Bcrypt. Okay. So one of the safer versions for crypting would be Bcrypt, password hashing function designed in 1999. That's crazy. Yeah, this would be. And another important, like, which algorithm is used to store etc the passwords, or it's a shadow. Bcrypt, SHA, Bcrypt, SHA, and SHAS. What hashing does Git use for objects? So I have another question. Why does Git use SHA-1? Git uses SHA-1 for hashing objects. Content addressing, data integrity, efficiency, supporting Git, generate hashes. So yeah, thing is, it's not that if SHA has collisions, how would a Git handle a SHA-1 collision on a blob? Alright, this is a little off topic, but let's read this. This probably never happened in the real world yet, and may never happen. But let's consider this. Say you have a Git repo, make a commit, and get a very unlucky. One of the blobs end up having the same SHA as another that is already in your repo. Question: how would Git handle this? Simply fail? Find a way to link two blobs and check which one is needed according to the context? I did an experiment to find out exactly how Git would behave. Oh, by the way, this is posted 13 years ago. Damn. Behave this is with versions. I basically just reduced the hash size from 160 to 4-bit by applying the following diff and rebuilding Git. Then I did a few comments and noticed the following. If a blob already exists with the same hash, you will not get any warnings at all. Everything seems to be okay, but when you push someone clones or you revert, you will lose the latest version. In line, if a blob already exists with the same hash, if a tree object already, everything will seem normal until you try to push it, but then you will see the repo is corrupt. If a commit object already exists and you make a blob with the same hash, number 2, corrupt. So it gets corrupted and you get an error. It's a tree, not a blob. Bad blob, failed some ref to origin. And you make tree objects. Yeah. Um, Injection. Injection is the third. Um, Injection flows are very common in applications today. These flows occur because the application interprets user-controlled input as commands or parameters. Injection attack depends on what technologies are used and how these technologies interpret the input. SQL injection, command injection using allow list when input is Yeah, I have another question. Is a white box or black box input sanitization better in case of injection attacks? Injection, command injection, PHP, get request, cow is at cow, pass through. So pass through function is simply executes a command in the operating system's console and sends the output back to the user's browser. You can see that our command is formed by concatenating the cow and mooing variables, since mooing is taken from the insecure design. Insecure design refers to vulnerabilities which are inherent to the application's architecture. They are vulnerabilities regarding bad implementations or configurations, but the idea behind the whole application is flawed from the start. Most time, these vulnerabilities occur when an improper threat modeling is made during the planning phases of the application. Some other times, insecure design vulnerabilities may be introduced by developers while adding some shortcuts. Insecure power password resets occurred on Instagram a while ago. Instagram allowed users to reset their forgotten passwords by sending them a 6-digit code to their mobile number via SMS validation. If an attacker wanted to access a victim's account, he could try to brute force the 6-digit code as expected. This was not directly possible as Instagram had rate limiting, so that after 250 attempts, the user would be blocked from trying further. However, this was found that the rate limiting only applied to code attempts made from the same IP. If an attacker had several different IP addresses from where they sent requests, he would now try per IP 250 codes per IP. For a 6-digit code, you have million possible codes. So an attacker would need 4,000 IPs to cover all possible codes. This may sound like an insane amount of IPs to have, but cloud services make it easy to get them at relatively small cost, making this attack feasible. How much money would I need to get 4,000 different IPs for sending a request? Well, it just $200. That's crazy. That's crazy. I think you can realistically do that with a couple $100. You can send that many requests. Security misconfigurations, for example, a Flask can have, alright, this is easy. Security logging and monitoring failures. As you may have noticed, logging is more important after breach has occurred. The ideal case is to have monitoring in place to detect any suspicious activity. The aim for detecting this activity is to either stop the attacker complexity or reduce the impact they have made if their presence has been detected much later than anticipated. Common examples of suspicious activity include common payloads in web applications. It's common for attackers to use known payloads. Detecting the use of these payloads can indicate the presence of someone conducting unauthorized malicious testing on applications. SSRF. Think. Web application that uses external API to send SMS notifications to its clients for each email. This website needs to make a web request to the SMS provider server to send the content of the message to be sent. Since the SMS provider charges per message, they require you to add a secret key, which they pre-assign to you. To each requester make an API. The API serves as an authentication token, key. Yeah, so through SSRF attack, you can change this server to attack another. No. Send requests to attacker. So I will send. So instead of this SMS service server, I will give them an attacker server. So all the requests will come to me instead of SMS, and then I will intercept those requests. ABC, I could then just capture content of request. Okay, this is a really basic case of SSRF. It doesn't look that scary. SSRF can actually be used to do much more in general, depending on the specific SSRF can be used for enumerate internal networks, including IP addresses and ports. A business relationship, trust relationship, interact with non-IP. All right, so data integrity, failures. software integrity failures. Integrity failures. Vulnerable and outdated components, insecure design, command injection. Okay. You know what? I want to make. All right, I read this. They also have an old top 10, which was first was injection, broken authentication, then was XML injection, external identity. I think these just OWASP. Yeah, so this is what happened. I think this is an important thing. No, open image. Yeah, this is an important image. We had injection and we had cross-site scripting. And cross-site scripting got merged into injection, which makes a lot of sense. You're just injecting JavaScript. Insecure deserialization got merged into software and data integrity failures. SSRF is new. Insecure design is new. Injection got downgraded to broken access control. Security misconfiguration. Security design. What got merged into what? XXE got merged into security misconfigurations. Yeah, I think it's very important to bridge. I think it's very important to bridge between OWASP business language and technical language. And I will do that very soon. All right, I looked into this. And I will look into web security, not now, because I'm just kind of like... Now I'll go through pipeline automation stuff. Humans are always looking for simpler and more efficient ways to do things. Just as we started programming and developing software, we were looking to automate some of the tasks. Automation is heavily ingrained in the software development lifecycle and DevOps processes. DevOps stands for practices, tools, and cultural philosophy that automate and integrate the processes to build software. While this is incredibly good for production, allowing for faster development, it does however introduce new security risks. When these processes are manual, an attacker could have compromised the credential workstation. The individual that performs the process, automation attacker can now go after the pipeline itself. Whoa. Following concepts. So, before learning about automation security, we should start by defining the pipeline and showing where automation can take place. The diagram below shows what typical pipeline can look like, as well as the software that could be used for this purpose. So you have a source code storage and version control, and then you have a continuous integration tool. You have which deploy Yeah, now let's just read. Let's take a closer look at automated testing. In the old days, testing was quite tedious and manual process. When talking about automated testing in pipeline, this will be first type of testing that most developers and software engineers are familiar with. A unit test is a test case for small part of application or service. The idea is to test application in smaller parts to ensure that the functionality works as it should. In modern pipelines, unit testing can be used as quality gates. Test cases can be integrated into the continuous integration and continuous deployment part of the pipeline, where build will be stopped from progressing if these test cases fail. However, unit testing is usually focused on functionality and not security. Integration testing, where unit tests focus on small parts of the application. Integration testing focuses on how small parts work together. Similar to unit test, testing will be performed for each of the integrations and can also be integrated into CI/CD part of pipeline. A subset of integration testing is regression testing, which aims to ensure that a new feature does not adversely impact existing features and functionality. Security testing, so if the first two types of automated testing are not security testing, which are it's not usually performed for security testing. Unit testing are feature testing and they test functionality, they don't test the security. Static application security testing works by reviewing source code of the application or service to identify source vulnerabilities. SAST tools can be used to scan source code for vulnerabilities. This can be integrated into development process to already highlight potential issues to developers as they are writing code. We can also integrate into CI/CD process as not quality gates, but as security gates, preventing the pipeline from continuing if SAST tool will detect vulnerabilities. DAST is similar to SAST but performs dynamic testing. This allows DAST tools to detect additional vulnerabilities that would not be possible with just source code review. One method that DAST tool used to find additional vulnerabilities, such as cross-site, to find by creating sources and sinks. When DAST tool provides input to a field in the application, it marks a source. When the data is returned by application, it looks for the specific parameter. Again, if it finds it, it will mark it as a sink. It can then send potentially malicious data to the source, and depending on what is displayed at the sink, determine if there's a vulnerability such as XSS or so on. Penetration tests, to scale full manual testing such as penetration tests. There have been significant advancements in automated tests, and even in some cases these techniques were combined with more modern approaches to create new testing techniques such as interactive application security tests and runtime application protection, security protection, self-protection. However, main issue remains that these tools, including this modern testing techniques, do not perform well against contextual vulnerabilities. Take the process flow of a payment, for example. A common vulnerability is when part of a process can be bypassed, for example, the credit card validation step. This is an easy test case to perform manually, but since it requires context, even DAST tooling will find it hard to discover the bypass. Similarly, business logic and access control flow are hard to discover using automated tools, whereas manual testing can discover them fairly quickly. It is not that automated tooling will never be able to find these flows, it is simply more cost effective to use manual testing. Common tools, GitHub and GitLab have built-in SAST tooling, such as Sneak. Tools such as SonarQube are also popular for SAST and DAST. Case study, she cannot take any more captain, she's gonna blow. What? Oh, she cannot take anymore, my captain. A common issue with SAST and DAST tooling is that the tooling is simply deployed into the pipeline, even simplify even simply for a POC. However, you need to take several things into consideration: performance, cost, integration points, calibration of results, quality and security gate implementation. First and last point is very important and can be costly if ignored. Initial POC of the tool should probably occur after hours, since it will have to scan through code. The process can impact performance of your source code control tool significantly. Imagine if this happening a big release, developers can on stage and push their latest commits. It's POC here. Yeah, so this room is just that will say on pipeline to get your flag review site. Pipeline. Oh, this is trash. Yeah. Yeah, this stuff is automation, like kind of like overread it. Sneak code and sneak open source. I just need to take a little break.